Okay, let's start. API description, the final frontier. These are the voyages of a Starship OpenAPI. Its mission to seek out new ideas and new use cases to describe strange APIs, to boldly go where almost no one has gone before. So before the OpenAPI Starship engage its warp drive, let me introduce myself again. So I'm Arnaud, I'm an architect at AXA Banque, a French bank. I'm also known as the API Handyman, the guy who wears lightsabers, funny t-shirts, and share his idea on Twitter and conference and blogs. I'm working on a new project, the API Stylebook. It's a website in which I'm gathering and analyzing all publicly available API design guidelines to provide categorized useful materials for API designers. So if you're aware of API design guidelines which are not on apistylebook.com, tell me. Today I want to share with you an OpenAPI trek, an epic journey from the dark corners of API documentation to the discovery of a boundless universe of possibilities. What will be told here is based on a true story, but it has been romanticized and dramatized a little bit to make it more entertaining. A long time ago, in a company not so far away, there was a mobile application plugged to an API. This mobile application and its API were a kind of black box handled by an external contractor team. One day, some people decided to create a new mobile application for a new product. This new mobile application was supposed to be developed by another contractor team. And it was supposed to reuse the existing API. This is a brilliant idea. This is why API are made for, to be reused. And what do you need to use an API? Everybody's sleeping, it's just after lunch. Okay, I give the answer. Documentation. Fortunately, for this new development team, there was an existing documentation. Unfortunately, for the new dev team, there was an existing documentation. This documentation was a huge PDF file intended only for the people working in the black box. This documentation was written by developers who generally don't care about documentation, and they don't care about this specific documentation because they knew really well how to use the API because they have built it. This documentation contained an unsorted, uncategorized, incomplete, and really raw description of this API. Endpoints were missing, properties were missing, errors were not described. With such documentation, the reuse of the API was quite complex. It slowed down the project, but the project succeeded. It just has been an epic adventure. Sometime after this, some people decided to create a new version of this API. Based on our previous experience, we decided to take care of the documentation matter seriously. We wanted an accurate and generated documentation instead of an incomplete and manual documentation. So we chose to generate this documentation from the code using Swagger annotation. Thanks to this magical annotation, we were able to generate a beautiful and interactive Swagger UI documentation. Cool. And then some people started to use this new API to build our new website and include banking functionality in another mobile application. And what did these people needed to use our API? Thank you for the two people in the back who are following me. Documentation. Fortunately for these people, there was a generated documentation. Unfortunately for these people, there was a generated documentation. This documentation was generated based on annotation in the code. And who has written this annotation? The same developers who wrote the late PDF file. And these guys still don't care about documentation. But it's not entirely their fault. The only given instruction was, we want a generated documentation with Swagger. And the only input we had was some crappy description written during API design by people who also don't care about documentation. There is no magic with Swagger annotation. If you don't provide all the information, you will not have a complete and accurate documentation. At least the generated documentation provided a complete list of endpoints, and we knew approximately what were the inputs and outputs, but it was incomplete. Properties were all optional. We had no description, and we don't knew how to use all these endpoints together. Icing on the cake, the documentation was organized from a technical point of view. As the new API was exposed by multiple modules, each module exposing its own Swagger UI. This was definitely not a comfortable situation. But we think we could solve it by updating the annotation. Unfortunately, it proved to be complex because the people able to write documentation were not able to modify the code directly. To update the documentation, we had to repackage and deploy the app, and at that time, deploying this application was a full manual and tricky process. So updating the documentation was impossible for us. We were in deep trouble. Fortunately, it was at that time that Swagger tools were updated to version 2. This new version made us realize that the annotation we put in our code were used to generate a file, a Swagger specification file, and that Swagger UI was only rendering this file. This generated file describes an API, and thanks to the new Swagger to edit online editor and YAML format, it can be written by humans, Vulcans, Klingons, and even Gorns. Just a brief aside about the Swagger OpenAPI thing. In November 2015, the Swagger specification has been donated to the OpenAPI initiative, which is an open governance structure under the Linux Foundation with many members. And the OpenAPI initiative aims to create, evolve, and promote a vendor-neutral API description format, the OpenAPI specification. To make it short, the OpenAPI specification is the Swagger 2 specification. There will be an update in a short moment, I hope. Is there some OpenAPI members here? No. Okay. So there we were, discovering this new API description format, which can be created by humans and used by machines. Mr. Spock find that interesting. This is far from the truth. This is awesome. We didn't knew yet at that time, but a boundless universe of possibility that would impact the full life cycle of our API was before us. The first step of this journey was to give up the idea of generating documentation from the code. All existing generated Swagger 1.2 files produced by our modules were converted to the new format as static files. These files were put on a web server with Swagger UI. There were many known and unknown technical issues to fix in this documentation that were still here after this conversion. And as I'm a lazy guy and as the OpenAPI specification is a machine readable format, I tried to find a way to detect and fix all these issues in one shot using some kind of script. And it proved to be incredibly easy to do. In no time, I developed a Node.js module which fixed many of these issues. It made me realize that the OpenAPI files are definitely easy to parse and modify, and that is what triggered my envy to extensively use this format. For the end users, this first step did not change anything, but it allowed us to decouple documentation from implementation. There are still many things to do to make this documentation usable, but at least we had a set of OpenAPI files which were valid regarding the specification and usable by any tools supporting the OpenAPI format, and most important, easy to update. This little change led to more big ones and has deeply impacted our whole API lifecycle. Let's see what we have done so far. So there was a lot of update to do on this documentation, and we needed to industrialize and secure these updates. We decided to consider documentation like software and the OpenAPI files just like code. So we have created a documentation continuous delivery system. Behind these mighty big words hide a real simple system. The OpenAPI files are in a Git repository, and on each commit, a Jenkins CI system checks that the files are valid and push them on the web server where we had this Swagger UI. Therefore, the people in charge of updating the documentation can update quickly and securely the documentation without depending on the deployment of the API implementation. Beyond the documentation content itself, its organization needed to be fixed too. It was too much tied to the implementation by modules. Our Swagger UI was exposing as many different files as we have modules, and this is not consumer-oriented. All we needed to do was to aggregate all these files into a single file to present this functional point of view. At that time, we thought it still made sense to keep separated files in a Git repository, so we decided to aggregate them only for the documentation. To achieve that, we have a Node.js module which run during the CI process, aggregate the documentation, and push them on the server. We also took this chance to add general information about how function the API in the master file, which is used to aggregate all the modules file. Our end user were really happy with this new, really cute documentation. Many of the resources used in the APIs present properties which values comes from a central dictionary. So we wanted to add these values in the documentation. So instead of copy-pasting from the central dictionary, which could have led to a real mess to sync these two sources of information, we had used an extension to indicate that a property corresponds to a dictionary class, and then during the CI process, this dictionary class value are retrieved and included in the documentation as enumeration and in description. All this automatically. And so this documentation is always up to date without doing anything. Later, the people who were updating the OpenAPI files started to complain about the files because they were getting too big, and the editor did not handle big files, and it was difficult to have a good functional views of the API, as some operations were spread over different modules. So we decided to give up the module view and switch to a functional point of view with different files, each file containing operations that are tied to functionality. This modification was not made by hand, but using, again, a Node.js module, including a full testing of the output to be sure that this internal modification was not impacting the resulting documentation. And we also added X implementation custom tags on each operation to keep the information telling us that this operation was exposed by a certain module. Documentation is not the only area where we use the OpenAPI specification. Some of our dev team use it to generate client code, but the most important change beside documentation which occurred by using the OpenAPI specification is on design time. For a long time, we had struggled to describe accurately and efficiently APIs on design time. So we started to use the OpenAPI specification, as it's easy to write with YAML and with the editor. And so the API designer can describe the API easily, efficiently, and quickly. And the result is managed within the documentation continuous delivery process, so the design can be shared and seen by anyone easily. But describing an API with the OpenAPI specification do not prevent to create an unusable API. So you can forget endpoints. If you want to change different codes, you can forget properties to change these codes. So we are using Prism to mock APIs during design time. It's really a basic mock, but it's helped the designer to play with its API and see if everything is working really well together. And we didn't reach the end of the OpenAPI universe possibility. Let's see what we want to do next. First, as I explained earlier, we have started to add information in the documentation that are only relevant for internal people, the people who are building the API. And we want to provide two different versions of the documentation. Documentation for the consumers, we are already providing, and the documentation for internal user, including full details of how the API is implemented, which SOAP service is used by this API endpoint, and so on. So we will add as much information as possible using extensions in the OpenAPI files, and we will generate two different documentation using our CI system. We also want to handle many different versions of the documentation. We don't know how we will do that, but we will do it. We also want to control during development that an API implementation conforms to its specification. We will use probably tools like Dread or Ready API to do that. And we also want to be sure to check that we do not bring breaking change. And a more ambitious thing, we also want to control that the API design conforms to guidelines by checking the case, the URL structure, CZ, HTTP verbs, HTTP status, but we also want to check the description, the vocabulary and text pattern used in description, because there are many simple things that can be automatically checked, and so it gives us more time to really have discussion about more important design matter that, oh, you don't have a use camel case. So there's still a long way to go, but based on what we have done and what we plan to do, I can already say that the OpenAPI format helps us to design better API, to create better documentation, but not only external. To paraphrase Obi-Wan Kenobi and Mr. Spock, I can tell you one thing: may the OpenAPI be with you, so your APIs live long and prosper. Thank you.
Great. We have time while we switch out here for some questions. Anybody have a question that they'd like to ask? All right, come right back.
Just a very quick question. You mentioned test at the end that you were going to use. You mentioned a couple of products to test your API against that spec. Could you just repeat those? I didn't quite get them for testing.
Do you mean how we will use them?
Yeah, how are you going to?
Okay, so with this test, we only want to check the interface contract. So with Dread, you can provide this tool an OpenAPI specification, and it will generate basic tests to check on each endpoint if the results correspond to the interface contract. These are really basic tests, but at least it will avoid that some developers forget to add some properties in messages.
Any other questions?